Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into DeepSeek-R1, a groundbreaking new AI model. It's a big deal, folks.
Yeah, I've been hearing whispers. What makes it so special? Is it just another LLM, or is there something truly revolutionary here?
Oh, it's revolutionary. It's not just another LLM, it's an open weights model, meaning the model's weights are publicly available. Plus, it offers smaller, distilled versions, making it accessible to a wider range of researchers and developers. But that's just the tip of the iceberg.
I see. So, open source and scalable. But what's the core innovation? What problem does it solve better than existing models?
Exactly. The real magic lies in its training method. It's designed to replicate the reasoning capabilities of models like OpenAI's O1, but with a more accessible and transparent approach. Think of it as a recipe for building a highly capable reasoning model.
A recipe? Interesting. Can you elaborate on the ingredients of this recipe?
Sure. It starts with a base model, similar to other LLMs, trained on a massive dataset. Then, it uses a three-step process: supervised fine-tuning, SFT, and interim high-quality reasoning, LLM, and finally, large-scale reinforcement learning, RL. The key is the clever use of RL to generate a massive dataset of reasoning examples, which is then used to train the final model.
So they essentially bootstrap the process? Using a less capable model to create training data for a more capable one?
Precisely. They use an intermediary reasoning model trained with relatively little data via RL to generate a huge amount of high-quality reasoning examples. This is where the real efficiency comes in. It's a brilliant workaround to the usual data bottleneck.
That's incredibly clever. But how does the RL process work in this context? I'm curious about the reward signals.
Right. The beauty of it is the automatic verification. For reasoning tasks like coding problems, you can automatically check if the generated code is valid, runs correctly, and meets the specified requirements. No more expensive human labeling for every single example.
Wow, that's a game changer. So essentially, they're using automated testing and code analysis to provide the reward signals for the RL algorithm?
Exactly. This automated feedback loop allows for massive scale training without the need for extensive human annotation. It's a huge step forward in terms of efficiency and scalability.
But doesn't this automated approach limit the types of problems the model can handle? What about more nuanced reasoning tasks that are harder to verify automatically?
That's a valid point. While the automated verification is a huge advantage, it does limit the scope to tasks with readily available automated verification methods. However, the model's architecture, using a mixture of experts, MoE layer, allows for specialization and potentially handling more complex tasks in the future.
So the MoE layers allow for specialization, handling diverse tasks beyond just automated verification? That's a smart design choice.
Absolutely. The MoE layers are a key component, enabling the model to handle a wider range of tasks and improve its efficiency. It's a sophisticated architecture designed for both reasoning and general-purpose LLM tasks. And, the model itself is a stack of transformer decoder blocks, 61 of them to be exact.
61. That's a substantial model. So, to summarize, DeepSeek-R1 leverages a clever combination of techniques: open weights, efficient RL training, automated verification, and a sophisticated MoE architecture to achieve state-of-the-art reasoning capabilities while maintaining accessibility. It's a significant contribution to the field.
You got it! It's a truly exciting development, pushing the boundaries of what's possible with LLMs. And remember, the model's weights are open, encouraging further research and development. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into DeepSeek-R1. Goodbye.
Bye-bye.